My AI skill got better while I slept. I wrote a description of what I wanted it to do, left Claude Code running experiments all night and woke up to a completely improved version that passed all my test cases without me touching the code. That's a pattern called AutoResearch, open sourced this month by Karpathy, the guy who ran AI at Tesla and co-founded OpenAI. And the hook you just heard? It was written by an AI skill that improved itself on a scale of 10 from 6.22 to 8.10 overnight using this exact method. In this video, I'll show you how with a real case study, 7 iterations, real scores, real data, step by step, and then I'll show you how to use it yourself. Let's get into it. So first, what actually is AutoResearch? Karpathy released this as a GitHub repo at the start of the month. The original idea is simple but powerful. You give an AI agent a small but real task. In Karpathy's case, it's training a language model. The agent modifies the code, runs a short experiment, checks if the result is improved, keeps or disregards the change, and repeats over and over autonomously. About 100 experiments at night while you sleep. The key insight is what Karpathy calls programming the program. You don't touch the code directly. Instead, you write a markdown file called program.md that acts as instructions for the AI agent. The agent reads those instructions, makes changes, tests them, and iterates. And by the way, before we go on, if you're the kind of person who actually builds with AI and doesn't just watch videos about it, I run a community called AI Creator Monetization Lab on Skool. All the files I'm about to walk through, they're all there in the Skool at just $9 a month. The link's in the description. In the structure, there's 3 files that matter. Prepare.py, which is a one-time setup file that downloads the data. Just don't touch this file. Train.py, the file that the AI agent actually edits. That's the model, the optimizer, the training loop. Everything in there is fair game for the agent. And program.md, and that's your instructions to the agent. This is the skill that drives the research. This is where you define what you want to optimize and how. The agent runs on a fixed 5-minute time budget per experiment. Each experiment either beats the previous and gets kept, or doesn't and gets discarded. Now that's where it gets really interesting for us. Karpathy built this for machine learning research on GPUs. But the pattern, define a goal, define a metric, let an AI agent iterate autonomously, applies to almost anything, and you don't need a GPU. The 5-step adaptation for Claude Code skills is define your goal, create an evaluation file, set up the iteration loop, let it run, and wake up to a better output. The key difference from Karpathy's original, instead of a pass-fail assertion, we use something called LLM as a judge. Here's what this means. Instead of a human reading every hook and deciding, is this good, which doesn't scale, we get a second AI to be the judge. We write a detailed set of rules, a rubric, that tells the judge exactly what to look for and how to score it. The judge AI reads the output, checks it against the rubric, and gives it a score from 1 to 10. Think of it like giving a really detailed marking scheme to a teaching assistant. They don't need to be creative, they just follow the criteria and grade consistently. And I proved this with a real case study, a YouTube hook writer skill. Here's what I started with. A Claude Code skill, basically a markdown file with instructions that writes the opening hook for YouTube videos. The first 5 to 10 seconds that determines whether someone keeps watching or clicks away. The question was, can AutoResearch make this skill measurably better? To answer that, I needed 3 things. First, a skills.md file. That's just a markdown document with instructions telling Claude how to write hooks. This is the thing that gets improved each iteration. Second, a rubric.md. This is the scoring sheet for the judge. It's a markdown file that says, here's what a great hook looks like, and here are the 4 things I want you to score, and here's exactly what each score means. And third, evals.json. 5 real video topics that we test every hook against. Things like AutoResearch with Claude Code, an AI influencer tutorial. Real topics, not just toy examples. Let me show you the rubric in detail. Binary pass-fail tests like is it under 30 words are too easy. My skill hit 100% on the first try. That doesn't tell me anything useful. So the rubric scores hooks on 4 dimensions, each from 1 to 10. The curiosity cap, does it create an opening loop the viewer needs to close? Specificity, does it use concrete numbers, tool names, timeframes? Pattern interrupt, do the first few words break the viewer's autopilot? Relevance preservation, does the hook honestly represent the video? And here's what makes this actually useful. Every score is anchored to observable, countable criteria, not just vibes. Take specificity. A 1 to 3 means 0 numbers, no tool names, no timeframes. A 4 to 6 means 1 vague detail, some tools or a few days. A 7 or 8 means 2 or more concrete details with named tools and exact numbers, and a 9 or 10, 3 or more precise facts, like 8,000 followers in 3 weeks using 3 tools. Pattern interrupt, a 1 to 3 is hey guys or in this video, generic openers. A 7 to 8 means the first 3 words break autopilot with a number, question or anomaly. A 9 to 10, the reader stops scrolling immediately. When a score comes back at 7.8, I know exactly what that means and what it would take to push it higher. That's the power of grounded anchors. The composite score is just the average of all 4 dimensions. Curiosity plus specificity plus pattern interrupt plus relevance divided by 4. Simple, average, equally weighted. So when our baseline scores 5.8 on curiosity, 7.0 on specificity, 4.2 on pattern interrupt and 7.8 on relevance, that gives us 24.8 divided by 4, which is 6.2. That 4.2 in pattern interrupt is dragging the whole thing down, and that's exactly what the composite tells you where to focus your next iteration. The rubric is calibrated to be harsh. A 7 is genuinely good, anything above 8 is rare, and critically the rubric is frozen. It never changes during the experiment, only the skill prompt changes. That's how you get a real signal. Let me walk you through what happened across the 7 iterations. This is the real data. So baseline, 6.22 out of 10. Without any skill, just raw Claude generating hooks, the composite score was 6.22. The biggest weakness, pattern interrupt, scoring just 4.2 out of 10. The hooks were opening with generic phrases like I built and I used, exactly the kind of thing viewers scroll past. Iteration 1 got us to 7.06, so we kept that one because it was better than the last. I added the core framework, the 4 qualities of a great hook, 3 worked examples and a strict output format. The score jumped from 6.22 to 7.06. The skill went from producing paragraph length openers with filler phrases to tight structured hooks, but pattern interrupt was still lagging at 5.8. So with iteration 2 I targeted the weakest dimension directly, added a pattern interrupt technique section to the skill prompt with 4 specific strategies. First, lead with the anomaly. Don't say I built an AI influencer, say this Instagram account gained 8,000 followers, she doesn't exist. Start with the weird part, not the setup. Second, contradict common belief. Say something your viewer thinks is wrong, like stop making YouTube tutorials on a tutorial channel. That makes people pause. Third, drop into the middle of the story, skip the background. Don't say, so I was experimenting with AI tools and eventually start at the moment something surprising happened. And number 4, use the unexpected number. I spent 6 hours a week or 30 seconds of video that would have cost $10,000. Specific numbers stop the scroll. I also banned weak openers. I built, I made, I created as first words. Pattern interrupt jumped from 5.8 to 7.0. Iteration 3 got us to 8.10. And for this, we tightened the word budget to 20 to 25 words maximum. Added the rule that hooks must end with the opening loop. Don't close it with, here's how, or let me show you. Leave the tension hanging. This pushed the curiosity gap and specificity to their highest levels. And here's the meta part. The hook for this video, the one about AutoResearch, went from this. What if I told you that you could go to sleep tonight and wake up tomorrow morning to find that your Claude Code skills had improved themselves automatically while you were dreaming? To this, my AI skill got better while I slept. I wrote a description of what I wanted it to do, left Claude Code running experiments all night and woke up to a completely improved version that passed my test cases without me touching code. That's the hook you heard at the start of this video. Pattern interrupt opener. Got better while I slept. Specific details, description, experiments, test cases. Ends with the transformation, not the signpost. This hook was optimized by the very pattern it describes. And here's our highest scoring example, 8.75 out of 10 from an AI influencer video. This Instagram account gained 8,000 followers in 3 weeks. She doesn't exist. I built her face, voice and content pipeline in one Saturday using 3 AI tools. Specific numbers, a massive pattern interrupt with she doesn't exist, ends with the open loop. Compare that to the baseline which opened with I created an entire AI influencer from scratch, 30 plus generic keywords. Now here's the fascinating part. Iterations 4 through to 7 all got disregarded. Iteration 4 tried adding escalating reveals, the idea that each sentence in the hook should be more surprising than the last, building tension like a staircase. The score dropped to 7.15. It just made the hooks feel too formulaic. Iteration 5 added casual voice guidelines. Write like you're texting a friend, use contradictions, keep it loose. Back to 7.65, still below our best. Iteration 6 swapped out the weakest example in the Skool prompt for a stronger one, 7.85. Close, but still no cigar. And iteration 7 added a common mistakes section. Basically a list of what not to do, like starting with a number followed by a boring explanation. 7.65. 4 consecutive attempts, none beat 8.10. This is the natural stopping condition for auto-research. When you hit a local optimum and multiple attempts can't beat it, the skill has converged. You're done. Right, now let me show you how to actually build this. I'm going to go fast. If you need the full install guide and every prerequisite, then that's available in our Skool community. The link's in the description. But if you've got Claude Code installed and a terminal open, then you can follow along right now. So first of all, I'm going to open up Claude terminal, and then I'm going to ask Claude to clone the Karpathy repo. Okay, so I've said clone Karpathy's AutoResearch repo from GitHub, read through program.md and the experiment loop. I want to understand the pattern. We're going to adapt it for YouTube hook writing instead of machine learning training. So Claude Code is going to pull it down, read through everything, the experiment runner, how program.md structures instructions, how it keeps and discards changes based on a metric. Now it understands the full pattern, which is key. You don't start from scratch. You give Claude Code the original recipe and tell it to cook something different. So next up, we're going to build the eval. And obviously this is a really critical part in the step. If your eval is something vague, like is this hook good, or rate this on a scale of 1 to 10, that's just going to be vibes. You're going to get random numbers and learn nothing. You need criteria that are concrete and observable. One approach is like a binary yes/no question. Does the hook describe a result or transformation, not just a feature? Is that yes or no? There's no gray area. You can feed the script into your LLM, ask 10 questions and get a score out of 10. There's just no subjectivity there then. But I go a slightly different route. Instead of binary, I use grounded scoring anchors, but the principle is the same. Every score has to be tied to something you can see in the text. So I'm going to tell Claude, now build me a hook writer skill using the auto-research pattern. I need 4 files, program.md for the experiment loop, skill.md for the skill prompt, a scoring rubric, and test cases. The rubric needs grounded anchors at every score level, not rate creativity from 1 to 10. I need observable criteria. The program.md should be the reference, skill.md as the only file the agent modifies. Initialize Git, commit everything, create a GitHub repo called YouTube hook writer skill, and push. And for this demo, I just added in a 5th dimension rather than the 4 that we had originally. So I've added in emotional charge as well. Okay, so whilst that's working, let's look at what it creates. So the rubric has 5 dimensions: pattern interrupt, curiosity gap, specificity, emotional charge, and economy. Each one is scored 1 to 5 with concrete anchors, as we specified in the presentation. So this is machine readable. The judge doesn't have to guess. Does this hook contain 2 or more named tools or exact figures? Yes or no. Does it open mid-action? Yes or no. That's the difference between an eval that works and an eval that's just kind of noise and not very useful. So the test cases.md has the 5 real video topics. So I didn't specify specifically which topics to use. So I'd probably recommend using ones that you're going to create, just so that it's kind of optimized on real world topics. But here we've got a technical tutorial, personal finance, a science explainer, fitness, health, and video essay. We've got 6 as well here: vlog and storytelling, product review gear. Wow, it's done 8. So an educational history. And we've got the program.md, which is the experiment loop. Only skill.md changes. That means that when the agent discards a failed experiment and does a git reset, the loop instructions survive. This is the same separation AutoResearch uses. Program.md tells the agent what to do. Train.py is the thing it modifies. So Claude Code initializes Git, commits all 4 files, creates the Git repository, and pushes them. So when this is done, we'll have everything backed up to GitHub in the cloud. Okay, so we're on to the fun part. So we're going to say to Claude, read program.md and start the experiment loop, establish the baseline first, then start iterating. Do 1 iteration. Because the base instructions are just iterate forever. We don't want to do that. We're just going to kind of iterate through just 1 time, just to check it's all working. And once we've got that result, we can kind of tell it to iterate through a number more times. Okay, so it reads program.md, understands the loop, reads skills.md, that's the prompt it's going to optimize, reads the rubric and test cases, so it knows how to score. Then it generates hooks for all 5 test topics, scores each one across 5 dimensions, and gets a baseline. It logs the scores to results.tsv and then logs every generated hook to this hooks output, so you can actually see the output and not just like the numbers. Then it's going to look at where it's weakest, make a change to the skill.md, and then add new steps based on what that weakest dimension is. So if we go to results.tsv, we can see it's got our baseline score there, which is actually already pretty high, 7.25. That's a pretty good baseline. If we go into hooks output, we can see what these baselines are. So these are all of the things that it tried in the first step. It's giving itself a pretty tough score to beat as a first step. 7.25 is pretty good already. Okay, we'll look at the results in a sec, but you can see here that it's decided to keep it because it's moved it from 7.25 to 7.45. So the change improved the score run. The curiosity gap jumped from 2.63 to 4.25 average. So we're going to keep that one. So let's look at the scoring output. Sorry, the results. As you can see, the baseline was 7.25 and now the second run was 7.45. So added show result hide clause and leave one door open principle for the curiosity gap. Interesting. So if we go to the hooks output, so it looks like it only kept one hook as history. So really it'd be quite good to be able to see all past history and see them change over time. So I think I'm going to prompt that for like the next iteration. Okay, so I said let's do one more iteration, and this time log not only the new hook but keep a history of the old ones as well, whether they pass or fail. Okay, so if we look at the results again, it looks like we got another keep. So we've got a really big jump here, up to the score of 8. So it says the description is we expanded the specificity principle, hide, explanation never, the data with concrete examples. So if we look at the outputs, we can see now we've got all of the history here. So we've got the baseline with all of the hooks that were put in here. We've got version 2, which we kept as well because it went up. And then we've got version 3, which is now score 8. And you can kind of see the results here. So if we just take one as an example, let's take this product review gear. So I blind tested a $47 Temu microphone against a 3,500 Neumann U87. 200 listeners voted and 41% picked the Temu. And if I go to this one, I blind tested a $47 Temu microphone against a 3,500 Neumann with 200 listeners. The results don't make sense until you understand one thing about how microphones actually work. And then the last one, I blind tested a $47 Temu microphone against $3,000 Neumann U87. Out of 200 listeners, 41% picked the Temu for voiceover. The reason had nothing to do with microphones themselves. So you can see like there's evolution there, and I don't actually know what the individual score was for that one because this is like a composite score. So actually it's got a composite score of 8.8 like overall. So if we look at this summary table here, we can see I actually picked the highest one by the looks of it, 8.8. So from version 2, it went up plus 0.8, and from the baseline, it went up from 0.8 before that as well. So that one's kind of improved quite a lot. So what I'm going to do is ask Claude to run this a number of iterations again, and this time we're going to just ask it to stop after it gets, let's just say 3 disregarded or failed improvements. Okay, so I said run iterations on a loop until we get 3 consecutive failed improvements, disregards, and then stop. Okay, so we got the results back finally. So it actually went through way more iterations than the first time I did it for this demo. So we got a couple of disregards in between, but then we kept improving until we got it up to 8.5 of our composite score across those 5 different dimensions. So I'm not going to go through every single change and kind of what happened because I think you kind of got the idea. But obviously we've got the scoring output here and we've got like all the hooks output. So we can see like the evolution over time and what was kept and the changes that were made. So we can just like go ahead and tweak this. So we can look at it from a human point of view and say, do we agree with kind of the results we got here? And is it better than kind of where we left off? But I'm going to leave it there because that's already been quite a long demo. But I'll make all of this available inside our Skool community, which is linked in the description. It's just $9 a month to stay ahead in AI. So here's the key takeaways, 3 things to remember. Number 1, freeze the judge, iterate the skill. The rubric never changes, only the skill.md prompt is modified. Number 2, target the weakest dimension, don't change everything at once. Pattern interrupt went from 4.2 to 7.0, one targeted change. Number 3, diminishing returns are the stop signal. After 4 consecutive discards, the skill has converged. AutoResearch is self-limiting. We took a skill from a score of 6.22 to 8.10. That's a 30% improvement through 3 targeted iterations. The improvement wasn't random. Each change was informed by the weakest scoring dimension. First structure, then pattern interrupt, then word economy. And we proved that AutoResearch has a natural stopping condition. The skill converged. 4 attempts couldn't beat it. That means this pattern is self-limiting. It doesn't burn credits forever. This is the shift. We're moving from a world where you manually tune your AI prompts to a world where AI tunes itself with measurable results. Karpathy showed this works for machine language research. I just showed you it works for everyday Claude Code skills. The people who learn this pattern are going to have a massive advantage because while everyone else is manually tweaking their prompts one at a time, you'll have an army of AI agents optimizing yours overnight. If you found this useful, hit the subscribe button. I break down the latest AI tools and techniques every single day so you can stay ahead of the curve. Drop a comment below. What skill are you going to run AutoResearch on first? I want to hear your ideas. And remember, everything I showed you today, the skills files, the rubric, the evals, the iteration playbook, it's all inside our Skool community, the AI Creator Monetization Lab. You get every Claude Code skill we build, the templates, and a community of people actually shipping with AI. It's $9. The link's in the description. Stop watching tutorials and start building. I'll see you in the next one.